could occur individually, and that tells you the number of ways that their conjunction could occur. That's our fundamental principle of counting, right? We also said that there is a nice little thing called a lattice diagram, a way of sort of picturing out what a particular scenario might look like. So I used the example of rolling a couple die, and we saw it was a 6x6 grid of 36 possibilities, and we go through and we pick possibilities match with the question. So along those same lines, still talking about rolling 2 dice, this question uses the negative. It says, find the probability, or what is the probability that you don't, or that you do not roll a sum greater than 4. And so what I would submit to you as we get started today on this first example is that the word don't might tip us off to that previous slide where we talked about what is called the complement of our event, okay? So like you'll remember on the previous slide, we talked about how sometimes it's easier to figure out the probability of your event not occurring and then just say, well, 1 minus that gives me the probability of the event occurring, right? Because the sum of the probability of my event and the probability that my event doesn't occur, called the complement, will always equal 1, right? Like, what are the chances that it rains today? 20%? Okay, what are the chances that it doesn't rain today? 80%. You know what I'm saying? So, like, that's a basic principle with probability that we can sort of use to sneak in the back door here on a problem like example 5. I'll show you what I mean. So it says, what is the probability that when you're rolling a die that you do not, or that you don't roll a sum greater than 4? Okay, I just rolled a 5, so I got it done. Actually, I guess I didn't get it done since it says don't. The hint says, find the probability that you do roll a sum greater than 4. So let's look at our lattice diagram here of 6x6. Right? And a sum greater than 4 would be where I've got maybe like a 4 and a 1, or a 3 and a 2, or a 2 and a 3, or 1 and a 4, or anything else sort of up and to the right. I know I have made this drawing for you guys before, so you kind of know what it's like. But any of these dots would be a sum greater than 4, right? And so I could go about counting. If it says, what's the probability that you do not roll a sum greater than 4? I could go about and I could count all of these, figure out what that probability would be, and subtract it from 1. Just the same, I could say, all right, well, what's the probability that you don't roll a sum greater than 4? I've got 1 here, 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 and here that I could also consider. All right. So like if I rolled a 1 and a 3, is that a sum that's greater than 4? No. So that would fit the bill of not rolling. So how many orange dots do we have? 6. So that probability would be 6 out of 36. How many green dots do we have? 30. There's 30. 30 out of 36, right? And what do those two add up to equal? They add up to equal 1. And so, and of course we would simplify them down, wouldn't we? We'd say this was 5/6, and this one is 1/6. And those, of course, still add up to equal 1. So the idea is figure out, based on what the problem is asking, which set is easier to count. It's much easier to count the orange one, okay? And in fact, that's what they were asking us for here. So we would just say, you know, here we go. But what if I changed the question up just a little bit? What if I changed the question and said, instead, give me just, or what if the probability question said, what's the probability that you do roll a sum greater than 4? Instead of counting all 30 of these green dots, I could simply count the 6 orange dots, figure out that probability, and then say 1 minus that. And 1 minus 1/6 would obviously give me 5/6. So that's that principle in action. Be smart about how you're counting. And I mean, obviously, this is a limited grid. This is 36, and we can sit here and count. But what if it was a larger number? Okay, what if there was a vastly larger number of possibilities? I wouldn't want to sit and count those all day. Sometimes it's more helpful to count the complement and just say 1 minus that. Okay. So that's a little tool at our disposal. We've kind of been talking about ways that we can help better visualize a problem. Here is our next tool. This is called a Venn diagram, right? And you and I have worked with Venn diagrams before. We did it back in chapter 3 when we were talking about compound inequalities, right? But jot this Venn diagram down. And for the rest of class today, we're going to talk about how this can be used in helping you visualize some more probability questions, right? So I like to use the example here of algebra students and basketball players, okay? So we're going to say that set A is the set of algebra students here at Christian Brothers High School. And set B is the set of basketball players at Christian Brothers High School. And by the way, the whole rectangle that refers to what's called our sample space, that's like the whole kit and caboodle. That's the whole school. That takes into account everybody. And so a Venn diagram like this, check this out, fellas. We could split it up into 4 distinct groups or types of people in this little scenario. All right. So let's first talk about the red dot. So that's a kid at Christian Brothers who does not take algebra and does not play basketball. Okay. How would you describe the blue dot? How would you describe the blue dot? Paul? Yeah, so it's a Christian Brothers student that takes algebra that does not play basketball. George, how about the green dot? It's a Christian Brothers student who does both. Takes algebra and plays basketball. And then lastly, Quentin, how would you describe the orange dot? Yeah, it's a Christian Brothers student who plays basketball and does not take algebra. So that's pretty easy. That's pretty self-explanatory, right? And there are indeed other types of Venn diagrams you might see. If 2 events are what are called independent or mutually exclusive events, they might look like this, right? So maybe this is the group of students that take algebra, and this is the group of students that take geometry. We don't have any kids that take both, right? So like there wouldn't be any overlap. There wouldn't be any intersection. Have you ever seen one of these before where maybe it's something like that, right? Where you've got 3 things and you might be in 2 of them, but not the third one, or you might be in all 3 of them right there in the middle, or you might not be in any of them. So these are all a variety of ways that you could visualize sets and subsets of people or of things, okay? So what I want to do now is I want to use a Venn diagram. I want to carefully walk through another probability example. And this one can easily be misconstrued if we don't read it carefully, okay? So let's read this out here. We've got a class of 25 students. So that describes my sample space, right? So in my sample space, I've got 25 students all together. So of my 4 groups, right, here, 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 and here, we're going to have a total of 25. Keep that in your mind. All right, so 8 have a brother. So we're going to say that, I'll do that in green. So that green circle represents the folks who have a brother. And then the orange circle represents the folks that have a sister. Okay. Now it says there's 10 students who do not have any siblings. So that's 10, what do you call it? Only children, right? So there would be 10 kids out here hanging out. They are in the class, but they just don't have any siblings. Okay. Now, the common mistake, the rookie mistake with a Venn diagram kind of probability question like this would be to come over here and say, oh, 8 have a brother. I'll just put an 8 right there. We don't want to do that. So don't do that. Okay. Because what that says is there are 8 students who have a brother and do not have a sister. Is that what that underlined statement said in green? No. That just says there's 8 that have a brother, okay? So check this out. I can say let X, I'm using blue, aren't I? I could say let X be the number of students who have both a brother and a sister, like my daughter Betsy. Betsy has a brother, Teddy, and a sister, Jenny. So she would, for instance, fit into that category, okay? Where she has a brother and she has a sister. My son Teddy would not. He does not have a brother, right? He's got 2 sisters. So like that little X right there is going to represent some unknown overlapped region, okay? Now what could I put in here, right here where my pen is, where I had written that 8 earlier? What could I put in here? What do you think, Tiago?
8 minus X?
Yes, very good. 8 minus X. And consequently, over here in this other, the last unknown region, we could put 12 minus X. Right? So that idea of X being the intersection, the overlap region, if it doesn't tell me how many are in there, let me use my unknown to stand for that. And then what did we say? 1, 2, 3, 4. What did we say? All 4 of these sections add up to equal. They will add up to equal 25. Quentin. All right, so how many people have a sister? Try again. Read an underlined statement in orange. Read it. 12 have a sister. Good. And if X of those also have a brother, then 12 minus X, get it? You get it? 12 minus X don't have a brother. It's like saying if I have 12 cookies in here, okay, and X of them are chocolate chip. Well, how many of them are not chocolate chip? 12 minus X, okay? So it's the same thing. It's the old thing that we've been talking about for a while now, that part 1 plus part 2 equals the whole, or the whole minus part 1 equals part 2. And we can represent it that way, okay? Now, what did we say we could write up? We could write up a nice, neat linear equation, 8 minus X plus 12 minus X plus 10. All that's supposed to equal 25. And I guess I can fit that in right there. So we have described all of our students, the only children, the folks that have a sister only, the folks that have a brother only, and the folks that have both a brother and a sister. There's no other subset of students in this experiment. And so we've got ourselves a nice, neat linear equation. And let's see if we can solve that out. Minus X plus X is going to cancel out. 8 and 12 makes 20, and 10 makes 30. So I'm just checking off these numbers. 30 minus X equals 25. So X must equal what?
5.
X must equal 5. And now I start to fill in what's going on. There's a 5 there. 12 minus 5 leaves me with 7. 8 minus 5 leaves me with 3. And now I've got all 25 kids accounted for, right? There's 3 kids that have a brother and not a sister. There's 5 that have a brother and a sister. There's 7 that have a sister and not a brother. And there's 10 only children. Okay? Now, we could have done this, and my freshman yesterday, we did this without doing the algebra. We just did like some kind of common sense, right? So let me make sure that you guys can do that as well. I like a common sense approach to a problem. So if you are like me, if you are a fan of the common sense, this explanation will make sense. And if it doesn't, then you can obviously default back to the algebra. All right, but pretend those numbers are not there on my Venn diagram. Pretend I don't have any numbers other than the 10 right here, okay? What does that mean that I have left over? If there are 10 only children, then how many kids are there that would comprise what's called the union of these two sets? In other words, brother or sister or both. We've got 15. There are 15. We know that with certainty. How many are there, class? 15. There are 15. Now, what's 8 plus 12? 20. So we have counted one group, this middle group, twice. That's like saying I'm going to count the green circle, and I'm going to count the orange circle, and I'm going to add those two up. Well, obviously, we've counted the overlap region twice. So what is 8 plus 12? And we said this was supposed to be 15, so how many did we count twice? We counted 5 twice, and we could put the 5 there. I kind of like that better than doing the algebra. Okay. Let me show you again. Different example, but we'll just verbalize this. Okay. Suppose that I teach 100 students algebra here at Christian Brothers, and suppose that on our basketball team there are 30 students. Okay. Does that mean that there are 130 altogether? No, because there might be what? There might be some kids that do both. And so if I want to figure out how many kids do both, right, then I can do that subtraction like we just showed. There's actually a formula for this, okay? There's a formula for this, and I'm about to write it down, and I want you guys to write it down too. All right? The union of 2 sets is equal to the number in the first set plus the number in the second set, but that's too many, right? We've counted too many, so we have to subtract the intersection of those 2 sets. It's a really fundamental formula for set theory, for counting sets and subsets of things. The U symbol right there is referred to as the union. So what that looks like visually, right, is it is A or B. Okay, so the union A union B. Another way of saying that is A or B, right? Just means A not B, B not A, or both. Okay, that's called the union. And the union equals A. Let's see if I can be consistent with my drawings here. There's A, there's B. It equals A plus B, right? But can you visually tell that we have now counted this middle section twice, right? You know what I'm saying? So like we have to do what? We have to subtract away, we have to take away that intersection. There's A, there's B, and we have to subtract away that doubly counted intersection. That's called A intersect B. What shorthand word do you think we use? It's not and. Excuse me. It's not or. It's and. Right. So that's the formula, sort of in a nutshell. There is that the union of 2 sets will equal the sum of the first set plus the second set minus their intersection. It should be real common sense. And I like that approach as opposed, in this context, as opposed to the algebra. Okay. So like you go back to a problem like this. Does everybody have a chance to get this down, by the way? Okay, I'll wait a second. Jake, do y'all have school today? Nice. I got a couple of Charlie and Luke. Y'all doing all right at home? Nice. So like when there's a couple of things that I would encourage you guys to do when we're looking at a probability question. Number one, you got to be able to visualize what they're asking. Okay, Venn diagram's helpful way of doing it. Bless you. But number two, you also have to read what they're asking. Make sure that the question makes sense. Okay, because what we're about to do is I'm about to show you. I made a mistake. Maybe I guess Monday. I was talking to my 7th period, and we worked through this problem on. It might have been Tuesday actually. And I just misread it, which is oftentimes we go, Paul. All right, which is oftentimes, the way that you miss a probabilities question is you misread it. Okay, so like I got the problem set up, got my Venn diagram set up. I was happy, with the 3 and the 5 and the 7 and the 10, and then all of a sudden I told the kids, okay, what's the probability that the student has a brother, also has a sister? And I said 5/25. I said, there it is. He's got a brother and a sister, and there's 25 kids in the class. That's not what they asked. They didn't say, what is the probability that a student in this class has both a brother and a sister? That would be 5 over 25, right? They said, what is the probability that a student who has a brother, how would you describe the number of students who have a brother? There are 8. Of those 8, what is the probability that a kid in that set also has a sister? And that's the answer to this question. So we have to be real careful about how the probability question is worded. And they're not going to be trying to trick you. They're just going to be asking the question, and we don't want to read it the wrong way. Okay? So this one says, what's the probability that a student who has a brother also has a sister? What if it said, what's the probability that a student who has a sister also has a brother? What would that probability be? It'd be 5 over 12. Because you asked yourself, how many kids have a sister? 12. And then how many also have a brother? 5. What if it said, what is the probability that a student in the class has a brother but does not have a sister? We would say 3 over 25. Okay? So a wide variety of ways that they could word a probability question, and we want to be prepared for all of those. Any questions that you wanted to ask about the Venn diagram or about this kind of word problem? All right, so here's what we're going to do. We are now finished with this lesson. I'm not going to go on to lesson 11.3 with you guys because y'all got your exam on Monday. So here's what we're going to do. We're going to talk about the exam, just broad strokes today, and then tomorrow we're going to spend some time maybe letting you ask some questions. I have a practice exam or two that we can pull some questions from and just sort of refresh our minds about what all we've learned this year. Okay, do you guys, y'all said y'all took exams, right? Or are y'all taking them next week? Next week, some people. Do your teachers give you like study guides and things for your exams? Or are you responsible for making your own?
That's what we get them.
Yeah. I don't want to burst your bubble, but a lot of times in high school you don't have one provided for you, okay? Your teacher's not necessarily, now some teachers do. Some teachers are fine and they say, hey, here's a practice exam. Here's a list of topics that we've studied this year. But a lot of times it's like, okay, you're on your own, bro. Study up, you know? So I want to talk with you guys for the next, 7 minutes and then in class tomorrow about not just what to study, but sort of how to study, okay? Now, one of the challenges for you guys is that we have not had a bunch of tests in here. Typically in a math class, you take a bunch of tests, don't you? And to study for an exam, I would always encourage a student, well, just take your old tests and rework them, like write the problem down over on a blank sheet of paper and then just practice working through those problems. But we don't have that this year, okay? What we do have, I don't know if I've got this pulled up yet or not, probably do not. What we do have is a slew of homework assignments that we have practiced all year long, okay? So I'm going to pull up, if it will allow me, I'm going to pull up Delta Math and just show you, kind of give you a look at, we'll pick on somebody and we'll say, okay, what are all of those assignments? Delta Math, here we go. And what's nice about this is that you can go back and you can practice, even if you've already done one of the homework problems or homework sets, you can go back and practice more of them. Like if I only assigned 5 of a particular type, you can certainly go back and practice, 20 more if you want to, okay? Now, some of you guys have not been doing your Delta Math. Shame on you. So if I embarrass anybody, I don't mean to here, but let's see here. What I can do is view assignments. And then view class. We can pull up early morning math. And we're just going to pick on who's the first one on my list. Tiago. Oh, Tiago. All right. So like what Tiago could do is he could go all the way back to September. Okay. And he could say, all right, I want to practice. I want to study for my exam. So Tiago pulls up this, and he says, all right, this was my old homework assignment. Ooh, let me practice converting decimals to fractions. And he just pulls one up, and he says, practice that. That is a great way to study for your exam. Jack? Yes, sir. So that's a great question. So y'all's exam in most of your math classes, if not all of your math classes here at Christian Brothers, will be cumulative. So that means that it will be from August all the way up through May. And I don't know, again, how y'all do things at y'all's schools, but that's how it will be while you're here at Christian Brothers. So, obviously, you guys can practice converting decimals into, and then you can say, oh, I want a new problem, and you can click on there. So that's number one. That's how we practice. Practice until you feel like you have mastered it. And then obviously, if it was a topic that you didn't feel real comfy with, like let's say, I think we did logarithms recently, didn't we? 10.3, maybe that was logs, I think. Yeah. Okay, so like let's say if it was a topic that you didn't feel very comfortable with, then you could say, all right, I want to jump in and I want to sort of triage where I stunk it up. Now, again, in a normal year, when I'm normally giving tests and whatnot, so like Alex would have like his, let's say, 15 tests that he took throughout the year, and he's like, oh man, I remember I bombed that test. So like Alex would take that and he would say, let me find the questions from that section, from that unit, and let me practice, let me study up, okay? Now, here's the structure of your exam. Here's what your exam is going to look like, okay? It is going to be 50 questions, all right? And you are going to start off with a grade of 50 out of 100. If you put your name on your paper and you turn it in, you're going to get a 50 out of 100, okay? And then each of these questions that you get right is going to give you another point. So if you get all 50 of them right, you get a what? A 100. If you get 10 of them right, you get a what? A 60, and so on and so forth. So how many do you have to get right to pass the exam? Yeah, I don't know what passing is here at Christian Brothers, do you? 65% or above is passing. So you would have to get 15 of them correct, right? Which is very, very doable. Very doable. And so, like, I'm not wanting you guys to shoot for passing. You're like, oh, man, if I just get a 65, I'm good. No, I want you guys to do really well. But we are going to be under some time constraints, right? Because you guys are only going to have about 50 minutes to take your exam. And I didn't really want to make a new exam. I had made this exam for my 9th graders, and I thought, you know what, I'm going to give it to my 8th graders and let them take it too. So what you guys will do is you'll come in here, and you probably will not finish all 50 questions. And is that okay? Everybody say yes. Yes. All right. You just do your best. You do the best you can do. You finish as many as you can. And there will be some questions that you could work in like 20 seconds. Okay. And then there will be some of those questions that you might need 2 minutes for. Right. There's a 3x3 system of equations on there. You're not going to solve a 3x3 system of equations in 20 seconds. Right? Now, if you're a real savvy test taker, you can use the test to help you take the test, right? It is a multiple choice / true-false test. So like, let's say on that multiple choice question, that's a 3x3 system of equations, you look at the first answer and you think, all right, instead of solving this system out, why don't I just plug those 3 numbers in and see if they work in all 3 equations? And you can quickly say, oh, that didn't work, and you can move on to the next one. So like, you can use the test to help you take the test. That's a good strategy, isn't it? Okay, but back to the logistics. You guys will show up on Monday morning. I want you here at 7 a.m. Okay, can y'all make sure you talk to mom, dad, whoever gives you a ride, and say, hey, Coach Morgan's exam is Monday morning. I really need to be here at 7 a.m. ready to start. You will need to bring a pencil. Okay, and I'll probably remind you guys of this tomorrow again. But you will need to bring a pencil. You do not have to have a calculator. Okay. But maybe bring some scratch paper. That would be helpful. I usually have a little bit of scratch paper, but I don't have a lot right now. So bring some scratch paper, and you'll be able to write on the test as well. It'll be printed on the front, and then the back of each page will be blank. So that can be some scratch paper for you as well. And hey, it'll just be like on the ACT when they say don't leave anything blank. I'll call like at 5 minutes till. I'll say, hey, we got 5 minutes left. And that's where you might just start making some, what do you call them, educated guesses. Or you might just start saying, okay, I didn't get to 10 of these. Let me figure out. And by the way, the last 10 are true and false. So if you're going to guess on one, that's usually the good one to guess on because you're already 50-50 as far as your chances go. Okay, and you can make an educated guess that way. Do y'all have any questions right now before we dismiss today and we go home and then we come back and practice tomorrow? Alex?
So we can bring a calculator.
Yeah, I think that would be okay. I don't think there's any problem on here that would require the use of a calculator. But if you want to bring one, you can. Anybody else? Jack?
Wouldn't we need a calculator for the logarithm?
No, you would not. The logarithm question is one that, and I'll show you, and I'll make up an example tomorrow if you will remind me, Jack. But yeah, it won't be asking you to evaluate the logarithm. It will be saying which of the following expressions is equivalent to this logarithm, to where you're supposed to manipulate this log and then say, oh yeah, it's that one, or it's that one, or it's that one. But I'll make up an example tomorrow. All right, so tomorrow I will have some practice problems that we will work through, okay? And we'll talk about maybe like a list of topics, although really it's just the whole year. And in the meantime, practice on some Delta Math stuff. And I hope you guys have a wonderful day. Thank you so much, and live Jesus in our hearts. All right, I'll see you guys.
Like my Delta Math login, I don't have.
Paul, you need to get your act together, brother. I'll be happy
Because
to.
it was saved on my Chromebook, and so I